The word plastic derives from the Greek plastikos, meaning capable of being shaped or molded. Since its mass production in the 1940s, plastic has been fantastic and abundant in all aspects of everyday life, mainly due to the material's wide range of applications. Petroleum-based polymers, of which polyethylene and polyethylene terephthalate are favoured due to their lightweight, good mechanical performance and good barrier properties, have been extensively used by the packaging industry. However, the convenience plastics offered led to a throwaway culture that revealed the material's dark side, and the realization that its environmental impact is far greater than initially perceived and has now become one of the main problems of modern society. Annually, around 360 million tons of plastic waste are produced worldwide, with the packaging industry accounting for almost 40% of it. At present, more than 98% of plastics are produced from non-renewable sources, which many of these have a lifespan of mere minutes to hours, yet they may persist in the environment for hundreds of years. The transition to a circular economy with reduced consumption of natural resources and the achievement of zero landfill by upgrading wastes into new raw material has become a priority in our society. The progressive substitution of consumer products derived from fossil fuels is also crucial to further decarbonize our everyday life. Efforts are made for exploiting alternatives for recycling methods which come with important limitations. 1. Mechanical recycling downgrades plastic properties, and 2. Chemical recycling for plastic depolymerization requires high energy input and long reaction times to be effective. The upPE-T project aims to upcycle PE and PET post-consumer packaging waste by developing biological catalysts called enzymes that aim to degrade them into ingredients that are biodegradable and recyclable bioplastics called PHBVs. Once these processes are scaled up, the biodegradable PHBV will be formulated and turned into actual demonstrator packaging products. For degrading PET, there are enzymes that have been proven to be able to hydrolyze this polyester, and upPE-T will find new candidates and improve upon them to develop an efficient and economic process for turning PET into the monomers terephthalic acid and ethylene glycol. For making a new, clear PET bottle, the TPA and EG from our process would need to meet very stringent purity thresholds, and therefore, in upPE-T we aim to use a lower grade TPA as a carbon source in the fermentation to produce bioplastics. For PE, the challenge of biodegradation is bigger. There have not been any convincing reports in the scientific literature demonstrating a true enzymatic degradation of PE into fragments. There are microbes and organisms like mealworms that supposedly can grow on PE, but the real molecular mechanism behind has not been solved. Also, the degradation is terribly slow, and there is no indication of which products are formed. However, we will use these reports and the diversity in nature as a starting point to launch a discovery program using computational methods of wet lab experimentation. PE degradation must go via an oxidative pathway, and we expect that the alcohol and acid products of PE degradation can be used as growth substrate in the fermentations to PHBV, just like the PET hydrolysis product TPA. By the end of its lifetime, the upPE-T project aims to achieve a semi-industrial scale while involving all key actors of the supply chain to take plastic waste through all the developed steps into PHBV packaging that can be field tested. The years following the project will bring additional positive impacts across Europe in terms of decreased CO2 emissions, 86% compared to conventional plastic production, 470 million kilos of PHBV per year produced, an estimated 424 million kilos of plastic not sent to landfilling, and the creation of 25 direct and 1,500 indirect jobs. We do this work within a consortium that is coordinated by CETEC in Spain and involves a total of 20 European partners and 10 countries from the entire value chain and fields of interest involved. An important part of the upPE-T project will be the continual assessment of the environmental impact of our solution in all aspects. It is important for you to know that you play a big part in the solution of the plastic waste problem. You have the choice of which packaging to buy and then have the responsibility to properly dispose or recycle the waste. However, we need to do this together, and we're here to help. So while we work on the technical challenges, you can start challenging your plastic waste habits. For all the science behind this, you can look at our website www.upPE-T.eu.